comparator compares voltages. If the non-inverting input is the biggest one, the output goes positive. If the inverting input is the biggest one, the output goes negative. Okay, so it'll either be plus 85% of 9 volts in this case, or minus 85% of 9 volts. A high signal and a low signal. So if the plus is biggest, it goes high. If the minus is biggest, it goes low. But that's not using the proper terms. The non-inverting one is the biggest of the two. The output goes plus 85% of 9. If the inverting input is biggest of the two, it goes minus 85% of 9. At the minute, my non-inverting input has got 8.1 volts attached to it. The inverting input depends on the temperature. Just now, the temperature is low, and this voltage is quite big. Right? So it's 8.1 at the non-inverting, 8.71 at the inverting one. So the inverting one is the highest of the two voltages, so the output goes low. Okay, it's minus 7 at the minute. Okay. As the temperature increases, you can see this voltage decreasing. Right, we're getting close to the other one now. Pop. There we go. So this voltage is 8.08, which is less than 8.1. So the non-inverting input has now got the biggest voltage, and the output is high. Okay, it remains high. Okay, and then when it comes down below 0 now, pop, there you go, it goes low. So when this voltage, when that voltage is less than that one, it goes high. Okay, and when this one is more than that one, it goes low. Now, I was switching this op-amp at 8.1 volts. I'm using a variable voltage supply to do that, but I could have used a voltage divider. Here I've got a voltage divider, that one there, I'm getting out 8.1 volts. I've got another one here, and I'm generating 7.2 volts. Right. Here's a voltage divider again, so that'll be 8.1 volts, and there is 7.2 volts. This comparator here, it's exactly the same as that one. Okay. The 8.1 is coming from here, there's my 8.1, and then I've got the thermistor and the 6.2 providing the input. I've now got a second comparator. Right? The inverting input is sharing the same as this one. They've both got the same voltage going in, dependent on this temperature. But the non-inverting one here, it's been compared with this voltage here, which is 7.2. So this one's 7.2, and that one's 8.1. So this one is going to switch at a different temperature to that one. So we're going to start off in the cold, and it's going to get hotter and hotter. Okay, there we go. That one's switching on at 0, like it did before. We keep going, and that one's switching on at about 20 degrees. Okay, so at 20 degrees, you can see, there we go. Remember that's 7.1, or 7.2, sorry. So that's 7.04, so that means that's 7.04 there, so that is less than the 7.2, so this one's high. And as the voltage drops, sorry, as the temperature drops, this voltage increases, so the inverting voltage is increasing, so that's one switched off, that's the other one switched off. Okay. Really, this is two separate circuits. You can think of the two comparators are two separate circuits. It just happens that they're using the same input thing to work it out. Okay, they're similar, but they're different. Okay, this one's comparing with 8.1 volts, this one's comparing with 7.2. Okay, so when it's cold, both op amps are off or low. As it gets hotter, first the top one switches on, and then the bottom one switches on. Okay. There's nothing to stop you just having two comparators and 3 resistors. If you've got a fourth resistor, you can get a third comparator. Okay, it can be more complex than this, but they're all just building on the single comparator circuit. You can just think of them as related comparator circuits.